Everyone, this is Dr. A. Kishore Kumar, working as Associate Professor in the Department of Robotics and Automation at Sri Ramakrishna Engineering College. In this lecture video, we are going to describe about the basic concepts of mobile robots and its introduction, which deals with the basic need and components of mobile robots and the localization and navigation aspect and the various challenges and the different locomotion mechanisms involved in this presentation. And these are the contents for this presentation: mobile robots, introduction, 4 pillars for the design of a mobile robot, components of a mobile robot, and robot locomotion mechanisms. And before entering into the video, like, we must know the basic definition of mobile robot. What actually it is a mobile robot? A robot that moves in its environment is called mobile robot, and mobile robot does not have any fixed a single location. So these mobile robots operates either in a structured or unstructured environments. For examples, autonomous vehicles, warehouse robots, and drones. And these are all the various important applications areas in almost all the major industries, the automation industries. So now, mobile robot is an automatic machine that is capable of locomotion. That is, in order to move the robot in and around the environment. So mobile robotics cover robots that roll, walk, fly, or sometimes swim. In the case of underwater mobile robots. So these mobile robots may travel on the ground, on the surface of bodies of water, underwater, and in the air. So these mobile robots are typically less structured in their operation and likely to use more number of sensors are involved. So now we need to know about the deployment of mobile robots and its the corresponding need to the industries. So these types of mobile robots perform tasks in hazardous environments, and it reduces human effort and cost, and it improve efficiency and accuracy. The major applications, if we concentrate, of these mobile robots are defense, healthcare industries, agricultural industries, and logistics. So now mobile robots need to answer 3 fundamental questions before the deployment. That is, in the mobile robot aspect, where am I? Where am I going? How do I get there? So these are the 3 basic questions that mobile robots need to answer. So to answer these basic questions, the robot must have, first, it make measurements and model the environment where it has to be deployed and localize itself. And based on the localization, we need to plan a path to its goal and control its motion. So these are the relevant answers for the basic 3 questions that mobile robots need to know. In this picture, there are 4 pillars for the design of a mobile robot. For example, if we want to design a mobile robot, we must know some sort of mechanics and electronics to be involved, and computing concept and mathematics aspect. So thus, the 4 pillars for the design of mobile robot deals with mechanics, electronics, computing, and mathematics. In this picture, we need to understand the mobile robot components, starting from the sensors, actuators, power supply, control system, navigation and mapping technologies, and communication systems. In this flow, we need to know about the basic understanding of the mobile robot components. If you see that sensors, the eyes and ears of robots, in order to perceive the environment, the sensors to be more number of sensors to be deployed. And actuators, the robot's muscle power. In order to implement a particular task, we need to know about the concept and the inclusion of actuators. Power supply, obviously the energy backbone of the robots, and the control systems, the brain behind the robot functions. Normally the controllers are involved here. And navigation and mapping technologies, to explore the technologies that allow robots to navigate and map their surroundings. So we need to incorporate these types of navigations technologies. And communication systems, we need to facilitate robot interaction with the human and as well as the environment. So thus, the mobile robot is a combination of various physical and computational components, like in terms of hardware and software planning. So that is classified as sensors, actuators, controllers, power supply, communication system, as discussed in the previous slide. So if you know about the sensors, we need to know the perception aspects of the environment. For that, lidar, camera, ultrasonic sensors are used. Actuators, motors, and some wheels are used. Controller, the normal microcontrollers, processors are employed. Power supply, battery, and the various communication system, the communication protocols are involved. So these are all the basic components of a mobile robot. And if we know about the mobile robot subsystems in terms of hardware components, a particular mobile robot can be considered as a collection of subsystems in terms of locomotion, sensing, and reasoning and control communication. So if you see about the locomotion, how the robot moves through its environment, because depending on the type of the deployment, we need to know about the locomotion aspect. And sensing, how the robot measures properties of itself and as well as the surrounding environment. Based on this, we need to know about the reasoning, how the robot maps the measurements into actions. So based on these actions, we need to control over the mobile robots. That's how the robot execute its planned actions. And communication, how the robot communicates with an outside operator. So these are all the mobile robot subsystems in terms of hardware components. And mobile robotics is very interdisciplinary because there is a diverse set of challenges in robotic systems. For example, in terms of locomotion, perception, and navigation aspect. So locomotion involves the mechanisms and kinematics like forward and reverse kinematics and dynamics control. Perception involves signal analysis, computer vision, and sensor technology. Navigation involves computer algorithms, information theory, probability theory, and information theory. So that's based on the classification, that based on locomotion and control. Now we can able to classify the mobile robots in terms of locomotion, wheeled robots, legged robots, tracked robots, and aerial robots, so-called unmanned aerial vehicles, so-called drones. Based on the control, autonomous, semi-autonomous, and teleoperated. So these are all the basic classification of mobile robots. And if we concentrate on the locomotion mechanisms in the mobile robot, we can exhibit the number of locomotions like as stated: wheeled locomotion, differential drive, and Ackermann steering, leg locomotion, by quadruped, track locomotion. If you see about the wheel locomotion, these movement using wheels offering high efficiency and speed on smooth surfaces. So most of the industrial scenario, you can able to find these types of wheeled mobile robots. Differential drive. So here a wheeled mechanism where two independently driven wheels control direction and rotations are employed. Ackermann steering, a steering geometry where front wheels turn at different angles for smooth cornering, like in some cars it has been employed. Leg locomotion, movement using articulated legs, suitable for uneven and rough terrains. So this comes under legged robots. Biped and quadruped, a type of legged motion using two legs or sometimes the four legs, six legs, similar to a human walking, can employ. And track locomotion, so movement using continuous tracks, ideal for rough and slippery or uneven surfaces. We can go for these types of track locomotion. So these are all the possible locomotion mechanisms involved in the mobile robots. And as discussed, sensors in mobile robots, there are two broad aspects of sensor: proprioceptive sensors and extraceptive sensors. Under the first category, encoders and IMU sensors are involved. And second category, lidar, cameras, and ultrasonic sensors are involved. So here, all these, both your proprioceptive and extra sensors, are used for environmental perception. And whenever if we speak about mobile robots, we must know about the localization, mapping, and navigation. So localization is determining the robot position in its environment. The dead reckoning and GPS technique and sometimes SLAM algorithms, simultaneous localization mapping algorithms, are used in order to determine the robot position under the aspect of localization. Mapping, so after localization, we need to create a map of the environment. So for this mapping, grid maps, feature based maps are used. And basically these mapping are used for navigation aspect. So under navigation, path planning plus obstacle avoidance to be employed in the mobile robots, so that no, without any obstacle hitting, it has to reach its final destination. So for this, Dijkstra algorithms and ASTIC algorithms are employed. So obviously the navigation are for real-time decision making aspect. So now with this slide, no, we need to determine the various challenges in the mobile robotics deployment. So we have a localization errors, dynamic environments, sensor noise, power limitations, and real-time processing. So these are all the various challenges in mobile robotics depending on the different sensors employed. No? So we need to consider these challenges for the before the design and development of your mobile robotics. So thus, as a conclusion of this video lecture, mobile robots are a key to future automation, and it has been widely used in almost all the smart manufacturing industries, and it is wide applications across the various industries, starting from your healthcare, logistics, and various aspects of industries. And continuous advancements in artificial intelligence and sensing are employed in the concepts of perceiving the environment. So with this, we close this lecture presentation. Thank you.